We're on page 28. This is a good Monday reminder. Here we go. If my f prime is greater than 0, my slopes are positive and my function's increasing. If I were you, I would just let yourself know my function would look like that then. My function's going up if my f prime is greater than 0. What if my f prime is less than 0? Probably, or it's definitely going to be decreasing. My function's decreasing. What about that second derivative? If my second derivative is greater than 0, it's going to look like this. Woo! Now, do we agree with these words? That the slope of f is increasing. If this is all the things, and maybe it's important for you to note this, everything that I'm graphing here, these are f. What's f prime here? Negative. What's f prime here? 0. And f prime here? Positive. If I go from f prime is negative 0 to positive, would you agree my f primes are increasing? Right? So that's just another way to word it. And again, my function's concave up. If my second derivative is negative, my function is going to be concave down. Agreed. Are my slopes decreasing? What were my slopes here? Positive, 0, negative. If your grades go from positive zeros to negatives, are they decreasing? Yes. Yeah. Okay. So I just think that that's some good wording. Okay. Here we go. So you guys, for a sake of space, I need you to know this is the f prime graph. Here's the graph that these answers are based off of. It says, hey, graph of f prime is shown. Which of the following could be the graph of f? This is a good Monday reminder. This is f prime. These are my f graphs. What's f prime here? Not necessarily increasing. It's positive here. If my f prime is positive, what's my f prime over here? These are positive. So what does my function have to be doing? My function has to be increasing all of these times from 0 to 2 and from 3 to 4. My function has to be increasing. Mr. Brady, what's my function doing here? Sorry, I was increasing. What's my function doing here now? Oh, agreed. So we don't like A. What's my function doing here? And then decreasing again. And we got to be increasing all the way to 2. So I'm not down with A or B. He says probably C. Well, let's make it definitely C. Is my function increasing all the way to 2? Yes. Would you agree D is also increasing to 2? Yes. Okay. What does my function have to be doing from 2 to 3? Decreasing. Does it appear that my function is decreasing from 2 to 3? Yes. And here? Yes. Okay. And then we got to be increasing again. Wait, it doesn't necessarily have to be positive, does it? Yes. I feel like C and D are both viable right now because then it goes increasing again. Am I crazy?
But it's just like
my f prime is positive from 3 to 4. That just means that my function's increasing. Doesn't mean that my function has to be positive. Could be either at this point. You guys, what would you say my f double prime is here? Careful, my f double prime is, I'm looking for the word positive or negative.
Positive.
My f double prime is positive from 0 to 1. So my function has to be concave up from 0 to 1. From 0 to 1, does this look concave up? Yeah. It doesn't have a lot of concavity, but I'd say it's got that U-ish shape. From 0 to 1, would you agree that this has more of that N shape down? Yeah. So we're digging C? Yeah. I agree. And again, what's my f double prime here? Negative. So that means my function has to be concave down. Does it look like my function is concave down there? Yeah. And then, so I feel good. Okay. Here we go. Before we even look at any table, what does this mean? If my f prime is greater than 0, my function is increasing. I dig it. What if my f double prime is less than 0? Okay. Let's think about this real fast. My f primes have to be positive. You guys, if we found our slopes here,
yes.
What would you think my slope would be here, positive or negative? Slope is always change in y over change in x. Negative. So if I went 0 minus 2 over negative 2 minus 0, right? Y minus y over x minus x, that would get me 1, right? So this is going up by 1. What would this one be going up by? 3 over 2. 1.5.
7,
over
2,
3.5,
3, 2.
1.5. Agreed? Would you agree all those slopes are positive?
Yes.
Okay. Let's just go with that for real fast. Let's just go find if my slopes are going to be negative. What's this slope going to be?
Concave down.
8 minus 6 over negative 2 minus 0. Wouldn't that be a negative slope? So are we cool with just crossing B off as soon as we have a negative slope? What about over here?
Negative. No.
Why?
Well, no.
Wouldn't it be negative 12 plus 10 over negative 2 minus 0? And that would get me positive 1?
Yeah, but then negative 10.
Negative 5 over negative 2 is 2.5?
Plus.
Positive, yep. Negative 5 minus 3 over 2 minus 4. Negative 8 over negative 2 is 4. You digging that? Am I going too quick? I'm just doing a little y minus y. 3 minus 13 is negative 10. Over 4 minus 6 is negative 2. Negative 10 over negative 2 is 5? Yeah, he says. Ooh. But my slopes are positive the whole time.
Okay, never mind.
But we're gonna come back to that. Let's just look at D real fast. What are these slopes doing? Negative 10 to negative 2 would be 5. Is that right? Negative 5, so that'd be negative 7 over negative 2 is 3.5. 2 minus 6 is negative 4 over negative 2, 2. 6 to 7 is 1 half. Those are all positive. So I'm digging like A, C, and D all have positive slopes. Let's think about F double prime is negative.
Slowly.
My slopes are doing what? Of this function, my slopes were
Approaching 0.
positive, then my slopes are,
0.
and then my slopes are.
Negative.
If my grades go from positive 0 to negative, my grades are decreasing. My slopes need to be decreasing. Here, aren't they getting bigger and then they get smaller? So it's a little inconsistent. What are my slopes doing here? They're only increasing. What are my slopes doing here?
Decreasing.
Decreasing.
Can it be increasing and then decreasing?
Because for something to be concave down,
It has to only be decreasing.
my slopes have to go from positive 0 to negative. If I've got numbers that go from positive 0 to negative, they have to be decreasing. These are some just progress check questions. I think it's good from AP Classroom. I picked and chose some good ones. Good little Monday review here. Okay, peeps. What's it asking? This is a Monday review. Point of inflection is when what changes signs? F double prime. Write yourself a note. We're looking for when F double prime changes signs for a point of inflection. We got to tattoo that on ourselves. Guys, they gave us F double prime, so let's go do that. And then I heard someone say they also changed the window, and you are right. So let's go graph F double prime, which was x squared, cosine of, and Graham, make sure you're in radians, x squared plus 2x over 6. And I'm going to change my window. Graham, I love your thinking out loud, said no one ever.
They changed my window, my
I think it's
Y,
C.
or
Maybe
negative
B.
1 to 1.
I think it's C.
Oh, okay. I like what Greer just said. If we're looking when my F double prime changes signs,
Whoa.
everything above is positive, everything below is negative.
Definitely 2.
So I got to be looking to see what's going on at 0. So I'm going to go change my Y min to negative 1
My window is still.
to 1.
I think it's A. I agree.
And I think it's helpful to go ahead and draw yourself a sketch of the graph.
I think so.
And here's the graph of F double prime. If this is a graph of F double prime, where are we changing signs? Are we changing signs? Nelson, the back of your head is not going to help this. Are we changing signs here?
No.
What about here?
Yeah. Oh.
My F triple prime went from negative to positive. I don't care about that.
Right.
My F double prime is positive, positive, 0, positive, 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 positive,
Negative.
negative. We're looking for this point right here.
A. 2.229.
That's going to be second trace 0. Don't just trust those hooligans. Second trace 0. Touche. We're skipping that one. Here we go. Ooh, this is really good to do because we did this a week ago. Ready for this? It says, hey, where's the absolute maximum value.
Oh, we got a sign chart.
Well, check this out. Let me show you this. Ready? They're giving us a restrained value. So let's say this. This is my function, guys. Or even this could be my function. Ugh, I don't like that. This could be my function. Let's go with this one. You guys, do you agree that they gave it to us on a closed interval? So what are you going to call this over here?
The absolute min.
Absolute min.
Absolute max.
What are we going to call this?
Relative.
Relative max. Relative local min.
Absolutely.
Absolute max. Okay, wait, real fast. Could this one? What do I have right here?
Absolute min.
Absolute min. What do I have over here?
Absolute.
Local min.
Local min. What do I have?
Max.
Yeah, this would be my absolute max. So you guys, when they ask for the absolutes, all we got to go do is find those critical points. And that's when my first derivative equals 0 is undefined. And then I actually don't need a sign chart because they're asking what's the biggest value. What we got to look at, though, are my critical points and the endpoints. That's what we got to look at for absolutes. So let's go do it. Let's go find those critical points. What is f prime?
6x squared plus 6x.
F prime of x.
A lot of 6x.
It's getting me 6x squared plus 6x. He says that's never going to be undefined. I agree. It's going to be equal to 0 by factoring out a GCF. What's left?
X plus 1.
Agreed?
0 and negative 1.
Yes, he's saying my critical points are going to be when each of these equals 0. So I'm going to say when does 6x equal 0, when does x plus 1 equal 0,
0.
and we got my critical points to be 0 and negative 1. If they said, hey, where do we have a relative min or where do we have a relative max, we would go sign chart. When they want absolute, you just say, okay, I got to just see what is the value of my function at the endpoints and at my critical points and see what is the biggest value for a maximum. So how I write that is I say, what's f of? I just go smallest to biggest. It doesn't matter. -3, I'm going to go -1, 0, and 1. Again, all these are my critical points. -3 and 1. And my endpoints of -3 and 1. And my critical points. Okay, people, let's do some mental math together. Let's start with 1. It's going to be easier. You guys, if I plug 1 into my function, because they said, what's the absolute maximum value of my function f? I'm going to plug 1 in here. What's this going to get me? 2 plus 3 is 5 plus 1?
Hold on, man.
6. What if I plugged in a 0 up there?
1.
Dig it. How about a -1? How's that going to change it?
It's 2.
That'd get me a -2, right? Plus 3 is 1, plus 1 is 2.
Negative 26.
Michael, chill. -3 cubed
Negative 27.
times 2.
Negative 54.
Agreed. -3 squared
9.
times 3.
27.
Love it.
Negative 27 plus 1, negative 26.
Yeah, and if you're like, dude, I'm kind of struggling, but they're asking for a max value, do we agree that this would be negative? And we got some bigger values over here. So that max value is going to be 6. Let's practice it again. Absolute min.
Oh, no.
Absolute min.
Let me find f prime.
Let's go find f prime.
Cosine minus sine of x.
Cosine of x, derivative of cosine,
Negative sine.
negative sine. Is that going to be undefined anyway?
No.
Nah. Could it be equal to 0? Sure. Could we just hip check that negative sign over to the other side and make it a positive sign?
Yeah.
Sure. Yes, yes, agreed. You guys agree the cosine is the sign, the x coordinate is the y coordinate at 1/4 of a pi. I concur. I think that's great. And he knew that there was another time. Okay, so we got these 2 critical points, you guys. Because they're not asking for relative mins and maxes, we get to just plug these right into our function. But what also do we need to plug into our function?
0 and 2 pi.
Those endpoints, very good. So I'm going to say, what would my function be at 0? What would my function be at pi over 4? At 5 pi over 4, it doesn't matter what order you put these in, you guys. I typically just go smallest to biggest, but it does not matter. We're looking for a minimum value. We're looking for that y coordinate that's the smallest. Back into my function, the sign at 0, 0. Bless you. Plus the cosine at 0 is 1. 0 plus 1 gets me 1. They want the minimum value. Pi over 4. Sine of pi over 4? Yes, root 2 over 2. Plus another root 2 over 2. My girl said, that's going to get me 2 root 2s over 2. That's just going to get me root 2. Let's do it. If I put a 5 pi over 4 in there,
It's the same thing, it's negative.
they're both negative, right? They were negative root 2s over 2.
That's the absolute min.
Probably.
So negative root 2 over 2 and another negative root 2 over 2, you're saying is going to get me negative root 2?
Yeah.
Agreed.
The other one is 1 again.
And he's saying, well, if we're going all the way back to 2 pi, that's the same as 0. If I put a 2 pi in there, it's going to be 0 plus 1
And the value
is 1. And the value is going to be negative root 2. They could put 5 pi over 4 as an answer. Be so rude. But and that would be the answer if they said at what x value did the minimum occur at. Guys, we're going to skip 5. Yeah, let's do 6. Bless you. Before you even look anywhere, what is this? Love it. As soon as you see those words, f double prime is less than 0. What's this a graph of?
That's fine.
Did that copy well enough for you? I was hoping that it did. This is f prime. Maybe rewrite it if it didn't. How am I going to get f double prime in front of an f prime graph? It's the slope. What's the slope of f prime here?
Negative.
All right, negative. What's the slope of f prime here?
Positive.
Don't care about it. What's the slope of f prime here?
Negative.
Okay. So, Nelson, you're saying from negative 5 to negative 3, my f double primes would be negative. And from 1 to 6, Nelson, I agree.